The SAM2 Segment Anything Model version 2 released by Meta AI has been a very important foundational model for segmentation. Not only does it have the ability of segmentation, it also has the ability to segment and track an object through the temporal context, through the temporal window in a video. This makes SAM2 very popular and powerful. If you don't know about SAM2 or if you want to learn more, here is a video. We've made a video on our channel talking about SAM2 and also giving a demo on how you can get started with SAM2. Now, an obvious next step with SAM2 becomes automatically tagging the objects of interest in the video and then segmenting them using a foundational model like SAM or SAM2. The idea is that, for example, say you have a video in which you want to detect some cars, for example. SAM2 in itself cannot detect the car by itself. It needs to be prompted with certain pixels. In SAM2, you need to provide certain pixels of an object that you want, and then SAM2 is able to segment that object for you and give you the results. However, in an automated pipeline, you cannot go ahead and prompt SAM2 or provide those pixels. There has to be some way of automatically feeding those prompts of pixels or bounding boxes to SAM2 without any user input. And that is where a combination of object detector and segmentation model like SAM2 comes in handy. Whereas the object detector is able to detect the objects of interest in the scene, and then these objects and this information about the spatial context of that object is passed on to SAM2, and this powerful SAM2 model is able to then perform the segmentation and give you the output results. Now in this video we're going to talk about an approach that does exactly this. One step ahead, this approach is able to take textual inputs with regards to the objects of interest in the scene that you want detected and segmented, and hence using this model, you're able to not only specify the objects that are of interest to you, you're able to detect them, and you're able to get the segmentation masks for those objects. So let's go ahead and figure out how we're going to do it and see a demo of it. Stay tuned until the end. Welcome back to the channel, guys. My name is Roof. I'm an engineer at Convolve. At Convolve, we are building computer vision products using advanced computer vision and AI in order to help industries with improving their efficiency, safety, and compliance. To know more, here is our contact information. Feel free to contact us and we would be happy to talk to you. So let's talk about Grounded SAM2. Now, Grounded SAM2, here on the screen, you can see the GitHub repository. It's not any new research work, but it's just a pipeline that integrates different research works together in order to perform very cool tasks. So this is bringing in the Grounding Dino work that was a recent publication, recent work that came out. Then it's combining it with SAM2. It's combining it with some vision language models such as Florence. So let's take a look over here. Now guys, if we go to the paper here, this is the paper for Grounded SAM. Now Grounded SAM was using the SAM model. SAM2, Grounded SAM2 is basically replacing the SAM with SAM2, which is a newer version of the Segment Anything model. Now, if we look at this repository, we can see the entire code over here, which has been released. And just to give you a sense of what is this code doing, what are we after here, let's take a quick look at this demo video. So guys, this demo video over here, you can see that uh, the model is not only able to detect the object, it's able to segment that object of interest, and it's doing it pretty well. Now, talking about the main things in this particular repository, in this code base, the model is basically a foundational model pipeline. This is bringing in the Grounding Dino 1.5, Florence, Dino X, and SAM2 together in order to perform really amazing computer vision tasks. Now, in this particular demonstration, in this video, we're going to talk specifically about the Grounding Dino and SAM2 and how combining the two we can produce some great segmentation results. Let's first talk about the pipeline and how it works. On the screen here, you can see this diagram, and what is happening here is that an input image is fed into the Grounding Dino. The Grounding Dino then detects the object and gets the detected object, which forms as a prompt into the SAM2 model. Now, the SAM2 model can either take in points, it can take in bounding boxes, and it using that it is able to then segment the region of interest. For example, in this case, we submit this bounding box as the prompt, which is around this little girl. That is going to lead SAM2 into segmenting that little girl, and we will have the segmentation mask for this person then. Now, using this particular segmentation mask, we can further refine the output. Now, there are three different ways in which this can be done. One is, if we are using a point prompt, it can then further use the segmentation mask produced in phase 1 to get further points to refine the segmentation result. Or we can continue to use the box outputs, the bounding box outputs from the Grounding Dino in order to get the segmentation mask. Or we can use SAM2 mask prediction that was based on Grounding Dino output mask for SAM2 video prediction further on, right? So here we are either able to sample points from the initial mask that SAM2 produces, or we are able to secondly use directly the box prompt from Grounding Dino, or we can use the mask produced initially by SAM2 to further refine and get stable segmentation results here as in the output through the SAM2 tracking. Now, after doing all of this, you can see on the screen, this is the kind of demo we get out of this pipeline, where you can see that the Grounding Dino is able to detect the children in the video, and then those children are further segmented by SAM2 to get a very stable segmentation result, where you can see each child is being tracked separately, and the color of each child here depicts that, right? So the boy is in yellow, the segmentation mask is yellow, and for the girl it's green, and it stays that way, which distinguishes that particular object, that particular person is being tracked by SAM2 in this entire clip. All right, now that we have seen how the pipeline works, what are the main components of the pipeline and what the results look like, let's see how we can set it up, how we can use it. So on the screen here, you can see the installation instructions. Now guys, there are two ways. You can either use install it on a virtual environment on your PC, on your machine, or you can use a Docker container. The code, the repository has a Docker file that you can use. When I did my experiments here, I have set it up without Docker. So this is essentially the installation instructions. You need to install Torch Vision, and Torch Audio. You need to install Segment Anything 2 using this command in the repository, and then you have to install the Grounding Dino. Now guys, if you are installing it locally, please make sure you use a virtual environment. That will make your life easier, that will make things cleaner, and that is a good strategy to go ahead. Now, once you have run the installation, you have completed the installation, you can run the demonstration, you can run the pipeline using this command, python grounded SAM2 tracking demo.py. And let's just take a look at what this looks like. So guys, this is the code for this particular command. Now the step one here is setting up the environment and model initialization. So here all we're doing is essentially giving the path to the model checkpoint for SAM2 that we're going to use, the config file. We are setting up the video predictor, image model, image predictor, which again is the image predictor that is working using the Grounding Dino model. Now, herein we are initializing the Grounding Dino model uh, from Hugging Face, right? So this over here is essentially getting the weights and using the pre-trained weights in order to initialize your model. And this is where it gets interesting, right? So we need to give it a text prompt. Now guys, here we can give it some interesting text prompt from our input video. For example, in this case, I ran an experiment and I'm giving it human head, right? So in the previous demo I showed you, we were looking at children, right? So here is that demo again. Here the prompt was children, where the pipeline was able to find children. Now let's see if we are able to do a bit better, and instead of children we are able to only detect the head and track the head. So that is the task that we are doing right now. So we give it a prompt of human head. Next step is to give it the path to your video, to the images of the video. So this over here, notebooks, videos, bedroom, is the path where all the images are for this particular sequence that we are running it on. So let me just quickly show you over here. Inside bedroom, you'll see this, these are all the images of this particular sequence of video that we are running this on. Next is over here we are basically getting all the frames from that directory, and then we are initializing the video predictor. Next is we are prompting in step 2 Grounding Dino and SAM image predictor to get the box and mask for that particular specific frame, right? So here over here, when we are calling the processor, we are running Grounding Dino on that particular image with the text prompt that we have defined above, which was human head in this particular case, right? Now guys, once this is run, the results are being stored here. Now these results are essentially bounding boxes and other information, mostly bounding boxes that we'll use further. Next is prompt SAM image predictor to get the mask for the object, right? So here we are setting that image predictor, and we are essentially, after getting all the detection results, after the detections have been performed, here this line over here, we are basically just getting the bounding box coordinates that have been produced by the detector and saving them over here in this variable, and we are going to use them going forth in our further tasks, right? And the results or the labels for those particular boxes are also being saved over here. Now here we are essentially running prediction on all the input boxes and getting some initial masks for those particular objects of interest that our detector has detected, right? So giving the image predictor, after giving it the image, we are now saying that, you know, just run the prediction for SAM to get a segmentation mask on that particular image. Now this is an initial mask that further can be used to refine our predictions to get a stable prediction. So if we go back to this particular diagram, wherein we have now done step 1 and step 2 to get this initial mask, right? So we are here on this green step, and the next step now is to be able to go from this green box to this blue box by refining our predictions using the outputs that we have already gotten from Grounding Dino and the initial running of our SAM2. So now guys, step number 3 is register each object's positive points to the video predictor with separate add new points call. Now here in this section of the code, what we are doing is, and I'm not going to go into too much detail of the code, but a sense is that using the information we've gathered so far, and in order to get to this part, which is to be able to get stable tracking, we are now doing one of these three things over here, which is we are using the information we have so far in order to add new points, uh, either add new points or boxes to our already created segment mask. And you doing that, we are going to go from an initial mask to a stable segmentation mask. All right, guys. So after we are done through this process of refining, after registering each object's positive points to video predictor with separate add new points call, um, after doing this, we are able to then get the video predictor, which is essentially running the SAM2 tracking model now, to get the segmentation result for each frame. Now guys, after we are done with this step 3, which included trying to register more points, positive points, or boxes, uh, using our initial run of Grounding Dino and SAM2 to improve our um, uh, segmentations. Step 4 is to now propagate video predictor to get the segmentation result for each frame. Now this is basically our step 4, which is the SAM2 tracking, wherein we are using the um, SAM2 again on this information that we have gotten in step 3 to get stable segmentation results. After this is done, now we'll have the segmentation masks for each of the frame along with the bounding boxes, and then that is our final output, which in step 5 is just visualized across the image and being saved to files. Now let's take a look at what this looks like. So guys, we have already seen the children tracking demo, which is over here, right? And now let's take a look at what the output from the head demo that we just ran, the human head demo, looks like. So this is what it looks like, guys. So you can see that the human head is being detected. Now here you see there is a misdetection where two heads are being detected for the girl. For the guy, it's absolutely perfect. It's being detected and it's also being segmented. And again, don't forget, it's being tracked as well without any issues. The only thing is there are two heads being detected over here. Now again, I think you can fix this by adjusting the confidence threshold, and that's about it. Now guys, once we have this, let's try it on some other setup, wherein let's see if we can detect some cars in a highway setting. So let me show you what the input video for this may look like, or the input images may look like. And here it is for the car setup. This is what the input images would look like, where the cars are driving by this highway, and let's see if we can detect and segment cars through this particular setting, right? So we'll change this particular prompt to car. We'll change the path to the path where the cars are, which is notebooks videos slash car, and we will run this particular code again. So here is how you can run this code. Very simple. Grounded SAM2 tracking demo, and once this is run, we will get our outputs saved to the folder. So guys, we have completed the evaluation and the execution of the code with this car prompt, and let me show you what the results look like for this. So if we go into the demo, here is the car tracking demo, and here we can see the cars being tracked. Again guys, now you will see that the same car is being detected and it's being tracked not only the button box, but also the segmentation mask. It's really proper, really nice, and it's very powerful with regards to what all you can do with it. The segmentation, the tracking based on a textual prompt can be done here, and this is amazing, the quality of results we can see. So that was the grounded SAM2 pipeline that we have presented. We've gone over the basics of how this pipeline works. We have gone over how we can set it up and run it, and I've shown you some of the results. Now think about different settings and different, say, computer vision tasks in different industrial settings. You want to detect, segment certain things. You don't have to go from ground zero or ground up and start from scratch. These foundational models come in pretty handy when you're trying to perform any task, wherein with natural language you can give in instructions in order to detect or segment certain objects. Now guys, there is a limitation here. The SAM2 model has some speed limitations. It's not as fast as a real-time application would want, but there are some variants of SAM2 called mobile SAM or fast SAM, which are in terms of execution speed better. But again, with time these models will become better and will become more real-time. But so far, in terms of the quality of the results, it's pretty nice and it's pretty handy and something that you can definitely try out. That's it for this video, guys. If you like this video, please hit the like button, subscribe to the channel, and hit the bell icon so you are notified about any new video that we upload. If you think this may be helpful to any of your friends, any of your colleagues, any of your uh, acquaintances, feel free to forward this information to them, this video to them, if you think they may find it useful. If you are a computer vision enthusiast, you are interested in the field, you can get in touch with us. You want to talk about something, you want to discuss something, discuss cool ideas, bounce off ideas, discuss project ideas, or you are in an industry, you're facing some issues, you need help. Again, we are always open to discussions. That's how science progresses, by discussing and bouncing off ideas. Again, here is our contact information. We would be more than happy to chat with you. Again, thanks again for tuning, guys. Thanks a lot, and I'll see you in the next video.